Algebra 1, the Sensei Learning System, Lesson 30. We want to combine these two. In order to combine these two, we need to have the same denominator. So, let's see if we can create the same denominators. We'll push the 4 over, and then the 2 over here. We have an x and an x squared. The lowest common term will be a term that can contain both of these. We have x and x squared. The term that can contain both of these will be an x squared. There's an x and x squared, and there's an x squared and x. So this can contain both of these. Next, we have an x plus 2 and an x plus 2. We'll put a single x plus 2 here and a single x plus 2 here. This x plus 2 can contain this one, and this x plus 2 can be contained. Now let's look at the difference. The difference between these two denominators is that this denominator has more x's. So whatever is extra in the denominator will also add to the numerator. The difference between these two denominators is only a difference of multiplying by 1. So we'll multiply the 2 by 1. So what we end up getting is one denominator of x squared and x plus 2. 4 times x is 4x, and 2 times 1 is 2. So one denominator, and it combines the one denominator, and we are able to combine the numerators. Okay, once again, we have x to the 5th and x to the 8th. The least amount of x's that both can, the x to the 5 and x to the 8th can fit into is x to the 8th. Okay, and then we have x minus 5 on both. The 3 and the 2, we're just going to put those off to the side here. Okay, and now find the differences. The difference between these two denominators is that there's x to the 3rd addition here in the denominator. So we're going to put an x to the 3rd in addition to the numerator here. The difference between these two denominators right here is only a multiple of 1. So I'll say 2 times 1 here. So now we have one denominator of x to the 8th power times x minus 5. And 3 times x to the 3rd power is 3 times x to the 3rd power. Plus 2 times 1 is 2. Next. Okay, we want to combine these two denominators, so we have to make them the same. So we have an x to the 3rd and x to the 2nd. The amount of x's, the least amount of x's that can contain an x to the 3rd and x will be x to the 3rd. I have an x plus 2 here and x plus 2 here, and so we can have x plus 2 in both cases. That's the least amount. And then we have 7 here and a 1 there. Now the differences between this denominator and this denominator, there are no differences, only a factor of 1. So we'll say 7 times 1. The differences between these two denominators is that there's an extra x squared in addition to the x here. That's why we have x to the 3rd. So we'll multiply this by x squared to balance everything out. So we have one denominator of x to the 3rd and x plus 2. 7 times 1 will give us 7, plus 1 times x to the 2nd power will give us x to the 2nd power. Now just to put this in order, I'll put it as x squared first and then plus 7 all over x to the 3rd power over x plus 2, because we like descending order. Okay, here. Okay, we have x plus 2 to the 2nd power and x plus 2 to the 3rd power. The least common multiple will be x plus 2 to the 3rd power, because I can also find the x plus 2 to the 2nd power within this. So x plus 2 to the 3rd power is enough for this one and this one. Okay, now the 5 and the 3, place them there. The difference between these two is a multiple of 1 x plus 2. So we're going to put another x plus 2 here. The difference between this and this is a multiple of 1. Got x plus 2 to the 3rd power, x plus 2 to the 3rd power. So the multiple difference is just 1. And from here, We can distribute the 5 because this is a simple binomial, so we can get 5x plus 10. 3 times 1 gives us 3, and our denominator is x plus 2 all to the third power. From here we can collect like terms, so the 10 and the 3 can be collected, and we get 5x plus 13 all over x plus 3 all to the third power. Okay, here we can add these two fractions. We have common denominators, and we have x minus 4 to the fourth and x minus 4 to the third power. Okay, the least common will be the x minus 4 to the fourth power. X minus 4 to the fourth power, and then x minus 4 to the fourth power. There's a 4 here and a 3 there. The differences between these two denominators is only a factor of 1, so we're going to say 4 times 1. The difference between these two denominators is a factor of x minus 4 to the first power, essentially. Okay. Now, we have one denominator, x minus 4 to the fourth power. And 4 times 1 makes 4. And when I distribute my 3, I'll get a 3x minus 12. Now I can collect like terms. My denominator remains x minus 4 to the fourth power. The 3x will go first. It's the only x term. But the constants are 4 and negative 12 that can be added together and get a negative 8. Number 6. Okay. This is a x minus 2 to the third, and this is an x minus 2 to the first power. Understood 1. This will be my least common factor. So I'll get x minus 3 to the third power, and here we'll get x minus, 2, my fault, 2, x minus 2 to the third power. And we have a 3 here and a 1 there. Now the differences between the x minus 2 to the third power and this x minus 2 to the third power is simply a factor of 1. The difference between the x minus 2 here, which is sort of understood 1 power, and the x minus 2 here to the third power is x minus 2 to the second power. Now all this will be under 1 over 1 denominator of x minus 2 to the third power. 3 times 1 is 3. And 1 times x minus 2 to the second power is still just x minus 2 to the second power. Okay. We won't expand this. We'll keep it the same. But that can be expanded. Again, we can use this as an answer. But this can be expanded as, when we do a FOIL, x minus 2 times x minus 2 over x minus 2 to the third power. This becomes 3 plus x squared plus 4x plus 4. Sorry, that's minus 4. And that's all over x minus 2 to the third power. Then finally, we can combine like terms. We have our x squared. We have our negative 4x. And the 3 and the 4 can be combined to become a 7. And that's all over x minus 2 to the third power. Okay. On this one right here, our common denominators, the highest power is here, so this will be our least common multiple. So x plus 5 to the fourth power, and x plus 5 also to the fourth power. A 3 here, a 2 there. The difference between this denominator and this denominator is only a factor of 1. So I'll multiply the numerator by 1. The difference between these two will be x plus 5 to the second power. Okay, now let's write all of this under one denominator of x plus 5 to the fourth power. 3 times 1 is 3, plus, we can't distribute the 2 because there's a power here. So since there's binomial expansion we have to do here, and distributing by 2, I'm going to leave this as 2 times x plus 5 to the second power. In fact, I'll put this first because that has higher terms of x's. So 2 times x plus 5 all raised to the second power plus 3 all over x plus 5 raised to the fourth power. Okay, on this one, we have 3x to the fifth power and 3x to the third power. So this will become x3x to the third power raised to the, x plus 3 all to the fifth power, and x plus 3 all to the fifth power. 1 and 2 here. The differences here are a multiple of 1, but the differences here are a multiple of x plus 3 all squared. That's a 2 there. Okay, so that goes all into one denominator of x plus 3 all to the fifth power. 1 times 1 is 1, and this we will not expand. So I will put this first. So 2x plus 3 all to the second power, then plus 1, and all of that is over x plus 3 raised to the fifth power.